In this lecture, we'll continue our discussion on observability and constructibility, and we'll see what the observability and the constructibility gramians are. We'll consider the linear system shown here. We'll first discuss about the observability gramian. So for that, please recall observability is essentially trying to reconstruct what the states are at the beginning of the time interval. So what is x of t0? Okay. So we had y tilde to be defined as this, and y tilde was equal to c phi x0. We want to reconstruct x0 from the information of y tilde that we have here. Now to reconstruct x0 from y tilde, what we do is we pre-multiply both sides by phi transpose c transpose and integrate it over the time interval t0 to t1. So the moment we do this, what we essentially have is the LHS being equal to a matrix over the time interval t0 t1 multiplied by x0. Okay, where this matrix WO over the interval t0 t1 is nothing but integration over the time interval t0 t1 of phi a transpose c phi a. Okay, this WO is essentially known as the observability gramian. Okay, if I want to know what x0 is exactly, then WO has to be invertible. If WO is invertible, then x0 is exactly equal to this. Okay, so this is how I can reconstruct x0 from the information of the output and the input which are encoded in the y tilde. Okay, so if WO is invertible, then x0 can be reconstructed and x0 is going to be of this particular form. Okay, similarly, if we have the constructibility gramian denoted by WCN over the interval t0 t1, then the WCN is actually given by integration over the interval t0 t1 phi a transpose c transpose phi a. Now notice the difference between these. Even though the observability gramian and the constructibility gramian look similar, the arguments of the state transition matrix in observability gramian was dependent on t0, and the argument in the constructibility gramian is t1. Okay, so that is the difference between the constructibility gramian and the observability gramian that we have here. Now this is the constructibility gramian, and if the constructibility gramian is invertible, then x1 can be reconstructed as shown here, where y bar is essentially containing the information about the output y and the input u, provided x of t1 was x1. Okay, so this brings us to two things. One is the unobservable space is essentially the kernel of the observability gramian or the null space of the observability gramian, and the unconstructible subspace is the kernel of the constructibility gramian, also known as null space of the constructibility gramian, is the first thing. And the second thing that we have is the linear system that we have is observable on the time interval t0 t1 if and only if the rank of the observability gramian is equal to the order of the system that we are actually handling, okay, or order of the state space representation that we have in hand. Okay, so this essentially means that the kernel of the observability Gramian will only have the 0 vector. Similarly, the linear system is constructible over the time interval t0 t1 if the rank of the constructibility Gramian is equal to n, which is essentially the order of the state space representation for the linear system that we have in hand. This again ensures that the unconstructible subspace or the kernel of the constructibility Gramian only has only the 0 vector in it. Okay. So for a linear system to be observable, the constructibility Gramian should be a full rank, and for the linear system to be observable, the observability Gramian should be a full rank, and for the linear system to be constructible, the constructibility Gramian should have full rank. We'll stop here. Thank you.